of a blacksmith shop. Now we can work on the other components. We're going to need the fire pot right there, the hearth where the iron is heated. We're going to need to put our anvils together. We're going to need a vice spot and all the different tools for doing blacksmithing. Hey, keep joining us as we build this blacksmith shop. Make sure to subscribe. Thanks for watching today.
All right, so I thought that was very, very interesting about how a bellow is made. And so we're going to skip these couple of slides. Also, it's talking about how they built the first subway. And then now we're at properties of gases. So please write this down in your book. Properties of gases have to do with three variables: temperature, pressure, and volume. And we're only going to do one gas law today because I want to give y'all time to work on your robots, on what you're working on. So think of this as four corners. So if you would take your paper that I just handed you and fold it in half and then fold it in a fourth, please. You will want to have Boyle's Law at the very top. So properties of gases are affected by three variables: temperature, pressure, and volume. Gases have no defined volume. Gases are highly compressible. And gases are lighter than a liquid. So when we're talking about these properties of gases, we're talking about absolute pressure. Please write that word down, absolute pressure. When we're talking about absolute pressure in engineering, we're talking about pressure that are on gauges. Does not account for atmospheric pressure on all sides of the system. And that is gauge pressure. And then absolute pressure is atmospheric pressure plus gauge pressure. So you'll write those in whatever terms you want. Everybody good? Just let me know. Okay. So when we're talking about absolute pressure, we're using the letter P, and that stands for pounds per square inch. We are going to do some on PSI today. There's one practice problem on there, but we're going to relate it back to normal gas laws. So it's telling you that atmospheric pressure equals, please write that down, 14.7 pounds per inch squared. So and please write down the sample problem. If you have a gauge of 120 psi, the absolute pressure is you would take that number, add it to 14.7, and you would get 134.7 pounds per square inch squared.
So all absolute pressure is adding 14.7 to anything that says absolute pressure.
Correct. So here, we would have to have whatever the pressure the gauge says,
Add 14.
and then we have to add that also in it because it's not accurate. So when we're talking about absolute pressure, 0 Fahrenheit does not represent a true 0 degrees. Absolute 0 is negative 460 Fahrenheit. Please write that down. Absolute 0 temperature is measured in degrees called Rankins. Rankins, and this is very important for you for engineering, you have to take your Fahrenheit plus 460. So like it says here, if it's 65 degrees Fahrenheit, the absolute temperature, when we're talking about engineering, would be 525 Rankins. And this here is where it's going to be a little bit different in engineering compared to other things. Everybody good? Okay. So the first one that we want to talk about is Pascal law. So when we're talking about Pascal law, you have P, which is pressure, equals force divided by area. I would like you to write down the formula, and I also would like you to write down the data table that's on the right-hand side in your notes, please. So when we're starting to do some math, we will know what each symbol stands for, the name of it, and then the example units that we're going to use. So here is Pascal's law example. So what we have here is we have a word problem. And it says how much pressure can be produced at 3.0 inch diameter cylinder and 60 pounds of force. So what we do, first thing we're going to do is we're going to write down our variables and what we're looking for. We're going to take the formulas that are on the right-hand side and we're going to solve. If you would please write this down. You can write it any way that you want that will make sense to you so that when you have word problems dealing with Pascal's law, you will know how to do it. So if you look on the left-hand side, the first thing they're going to do is solve for area first. And to solve for area is pi r squared. So in your calculator, you would do pi, the radius, as it says in here, 1.50. And then they do the math and they get 7.07. Once they find out for the area, then they're able to solve for P. And remember that the radius would be half, right? Because it tells us the diameter is 3.0, so it would be half of that for the radius. And if I go too fast, remember the PowerPoint slide is here for you. So the perfect gas law, that's what we're going to be doing today. We're going to do the first perfect gas law, which is Boyle's law, okay? So when we're talking about Boyle's law, write this down, P1 times V1 equals P2 times V2. After you write that down, I would like you to get your worksheet out. So what we're going to do is we're going to only do one gas law here, okay? The very first one. So what they're doing here for other places beside engineering, we have different types of measurement of 1 ATM equals 760 millimeters of mercury equals 101.3 kilopascal equals 760 torr. 1 ATM and all of that equals. It's kind of like just a conversion number. So let's look at the first problem. It says in a 22.5 liter of nitrogen, there is 748 millimeters of mercury compressed at 725 millimeters of mercury at a constant temperature. What is my new volume? So the first thing we're going to do on our paper, P1, V1, P2, V2. Write that on your paper. So we're going to look and see what we have. So I know we have one volume, right? So our first volume is 22.5 liters. I know that the original pressure was 748 millimeters of mercury. And I also know my second pressure equals 725 millimeters of mercury. So I am looking for volume 2.
Can't you just multiply 22.5
Yes, ma'am, you can. So if this is my equation, P1 V1 equals P2 V2, and I'm looking for V2, does it make sense if I divide P2 for both sides? There's my formula. So my formula for this equation is P1 V1 divided by P2. Once we figure out what our equation is, the next thing we're going to do is just plug everything in. So we got 748 millimeters of mercury times our first volume, which is 22.5 liters. And we're going to divide that by our pressure 2, which is 725 millimeters of mercury.
There is 23.2 and
Thank you, ma'am.
over millimeters.
Yes, ma'am. So what I want you to do is, if you have a calculator, get it out. If you don't, open up your device. And I only want you to do this one problem today. Do the math. So it would be in liters. When you get that done, the only other thing I want you to do, so we can get started doing our build.
I think I took it off like, whoa.
Well, you know what? I know there is an option on this to give you a calculator. Let me see.
Mine doesn't work. It doesn't work. Well, I know, but
Go to Desmond.
I've tried that. It works, but
Look at Desmond's scientific calculator.
So this is what I want you to do. If you don't mind doing this, go ahead. We're going to go ahead and go to the next slide. What I would like you to do is I would like you to write this example out. And this is a little bit different because they have different units, but I want you to see an example of engineering. So on your paper, on your ISM book, go ahead and write this down for just this problem, and we're done. So if you look here, we still have our P1, P2, V2, and V1, but this time we're not using ATM and we're not using liters this time. We're using pounds and inches. Same concept as before, except you have one more step. Yes, ma'am. So no matter what it tells you the pressure is, you will always have to add in atmospheric pressure for it.